Hello friends, I welcome you in lecture number 6 on Fourier integral. In this lecture we will discuss one more question on finding Fourier cosine and sine integrals of a given function. First we recall the definition of Fourier cosine and sine integral. We know that Fourier cosine integral of function fx is given by fx equal to integral from 0 to infinity a omega cos omega x d omega, where a omega equal to 2 divided by pi 0 to infinity fx cos omega x integral with respect to x. If we have function of x here integral is with respect to omega. If we have function of omega here, integral is with respect to x. Similarly, Fourier sine integral of fx is given by integral from 0 to infinity b omega sin omega x d omega, where b omega is 2 divided by pi integral 0 to infinity fx sin omega x with respect to x. Now we discuss this example. Find the Fourier cosine and sine integrals of function fx equal to e raised to minus kx, where x is positive and k is also positive constant. X is positive means we have to consider Fourier cosine integral on the interval 0 to infinity. Whenever we have question of Fourier cosine or sine integral, our function will be defined in the half range, that is from 0 to infinity. And whenever we have question of finding Fourier integral, our function will be given as defined on the whole real line, that is minus infinity to infinity. So whenever we have half range, the question will be about Fourier cosine and sine integrals, and whenever we have full range, that is full real line, then we are given to find out Fourier integral of fx. Here we are asked to find out Fourier cosine and Fourier sine integrals. Therefore domain of function is from 0 to infinity. So it is given that x is positive, that is this function we have to consider on the interval 0 to infinity. First we decide what is Fourier cosine integral. So here we mention that first we obtain Fourier cosine integral of given function fx, and for Fourier cosine integral we have to decide what is a omega, and we have ready-made formula for a omega. A omega is given by 2 divided by pi integral from 0 to infinity fx cos omega x dx, and then we substitute value of fx and we integrate from 0 to infinity. Fx is e raised to minus kx. So in the next step we put fx equal to e raised to minus kx, and then we have ready-made formula for this type of function, which is product of exponential and cosine function. So using that formula, if you recall that formula, integral of e raised to ax times cos bx dx is equal to e raised to ax a cos bx plus b times sin bx divided by square of a plus square of b. So if we compare this function with this one e raised to ax cos bx, we can see value of a is minus k and b is omega. So now we use this formula and we obtain e raised to minus kx a cos bx. Value of a is minus k cos omega x plus b sin bx. B is omega, so here we write omega sin omega x divided by a square plus b square. Value of a is minus k, value of b is omega, and let me remove this. Here I have to write the limits of integral as x equal to 0 to x equal to infinity. So first we put x equal to infinity, and here we can see if we take x tending to infinity, we will have minus k into infinity, that is e raised to minus of k into infinity. Now k is given to be positive, therefore k into infinity is also positive, and k into infinity will be equal to infinity. Because k is positive, if we multiply infinity by positive real number, we have infinity, and we know that e raised to minus infinity is 0. So for x equal to infinity, this term will become 0. This function is having 0 value if we take x tending to infinity, because this cos and sin x are bounded, their values are always less than or equal to 1, and here we have 0 as x tending to infinity. Minus, when we take x equal to 0, I will have e raised to 0 here, that is 1. Here sin 0 will be there, and sin 0 is 0, and cos 0 is 1, and we are left with minus k divided by minus k square, that is k square plus omega square. And if we consider this negative into negative, it is positive, and we have 2 by pi k divided by k square plus omega square. So this is value of a omega, and once we obtain a omega, we have to use ready-made formula for Fourier cosine integral, 2 divided by pi k divided by k square plus omega square. And now we write down the Fourier cosine integral. Fourier cosine integral of fx is, our function fx is e raised to minus kx, and we know that it is continuous everywhere, therefore we can write equality here, and the integral is given by 0 to infinity a omega cos omega x integral with respect to omega, and then we substitute value of a omega, and this 2 by pi and k, this quantity is independent of omega, so that we can directly take outside integral, and we will keep this k square plus omega square inside the integral. So if we substitute a omega equal to this quantity, this 2k over pi is independent of omega, so that we directly write outside integral, and we will have cos omega x into 1 over k square plus omega square, that we can rewrite as cos omega x divided by k square plus omega square d omega, and function fx is e raised to minus kx. So we have expressed e raised to minus kx as a Fourier cosine integral from 0 to infinity cos omega x divided by k square plus omega square d omega. This is the Fourier cosine integral of given function. Similarly, we can decide Fourier sine integral. So now we try to obtain Fourier sine integral. Let me use another page for Fourier sine integral. So here we make the title that now we are finding Fourier sine integral, and for Fourier sine integral we have to decide what is b omega. So now we find out value of b omega using the formula b omega equal to 2 over pi integral from 0 to infinity fx multiplied with sine omega x, integral is with respect to x, and we substitute value of fx in the next step. Integral 0 to infinity fx is given by e raised to minus kx sine omega x dx, and now we use that formula e raised to ax into sine bx, integral is given by e raised to ax. In the formula of e raised to ax into cos bx, in this formula we have to interchange cosine and sine function, and this positive sign will be replaced by negative sign if we have sine bx. So this a as it is, we are writing a cos bx. If we have cos function, here we have sine function, so we write a sine bx. Here, because we have sine function, we put negative sign b into cos bx and divided by a square plus b square, and we can use this formula for this integral with a equal to minus k and b equal to omega, and we try to find out this integral using that formula. So 2 divided by pi e raised to minus kx, a is minus k, here we put minus k sin omega x minus b, b is omega, and here cos function minus omega cos omega x divided by minus of k square plus omega square. Limits of integral are from x equal to 0 to infinity. Upper limit is x is infinity, and if we take x equal to infinity, because k is positive, if we take x equal to infinity and k is positive, we have e raised to minus infinity equal to 0. So this is 0 for x tending to infinity, and for x equal to 0, first we write this denominator, which is k square plus omega square. For x equal to 0, this is e raised to 0, that is 1. Here we will have sine 0, which is 0, minus omega into cos 0. Cos 0 is 1, and we are left with minus omega for x equal to 0. And we can rewrite this as negative negative positive 2 by pi omega divided by k square plus omega square. This is value of b omega, and once we have b omega, we can write Fourier sine integral of fx. Therefore Fourier sine integral of fx is fx equal to integral from 0 to infinity. Formula is b omega sine omega x d omega. This is equal to, this 2 by pi is independent of omega, so that we write directly outside integral, and sine omega x into this quantity, so that we can write as omega sine omega x divided by k square plus omega square d omega, and our function fx is e raised to minus kx. Therefore we obtain e raised to minus kx equal to 2 by pi integral from 0 to infinity omega times sine omega x divided by k square plus omega square d omega, and here x is defined for all positive real numbers, that is fx is given for positive real numbers and value of k is positive. This is the Fourier sine integral representation of a function fx equal to e raised to minus kx. So here we have expressed given function e raised to minus kx as a Fourier cosine as well as Fourier sine integral. Now sometimes the same question can be asked in this way also. If you observe, consider this as a remark or not, if you observe from this equation, I can obtain value of this improper integral, integral 0 to infinity omega sine omega x divided by k square plus omega square d omega. This is equal to pi by 2 times e raised to minus kx. So sometimes your question can be asked in this way also, using Fourier sine integral, prove that, you have to prove that integral from 0 to infinity omega sine omega x divided by k square plus omega square d omega equal to pi by 2 e raised to minus kx, where x is positive, k is positive. So the same question can be asked in this way also. So here we have to repeat the same procedure which we have started from this step, Fourier sine integral, but we have to decide which function fx we have to consider. So that function fx can be taken as pi by 2 into e raised to minus kx. You can consider this as your fx, or you can ignore the constant multiple pi by 2 and you can start with fx equal to e raised to minus kx. Whenever you have this type of questions that prove that value of this integral is given by this function, then you have to observe your integral. If your integral contains only sine omega x, then it is Fourier sine integral, and in that case consider your right hand side function as fx and find its Fourier sine integral. Similarly, the Fourier cosine integral can be helpful in proving that value of this integral is also pi over 2k e raised to minus kx. They can ask you to prove that using Fourier cosine integral, prove that this integral can be given by pi divided by 2k e raised to minus kx. X is positive, k is positive. They can ask you to prove this type of things using Fourier integral. Then you can see that this Fourier integral contains only cosine function or cos omega x. It contains cos omega x, therefore you have to decide Fourier cosine integral of right hand side function, or you can simply consider fx equal to e raised to minus kx. You can ignore this constant, but don't ignore any variable term in the right hand side. So whenever you have this type of questions, then if your question contains only sine omega x, then you have to go for Fourier sine integral of right hand side function, and if your integral contains only cosine terms, then you have to go for Fourier cosine integral of your function. And if your right hand side contains cos omega x as well as sine omega x, then you have to go for Fourier integral representation of your right hand side function. So they generally ask this type of questions in the examination like this. So here your Fourier integral or integral contains only cos omega x, so we will go for Fourier cosine integral of this function. Similarly, here our function, our integral contains only sine omega x, therefore we will go for Fourier sine integral. Suppose we have this type of integral, just for the sake of understanding. Suppose I have this type of integral, cos omega x plus sine omega x divided by omega square plus 4 something. Then here this integral contains cosine as well as sine integral, cosine omega x as well as sine omega x. Therefore we have to decide Fourier integral of right hand side function, whatever right hand side is given. But if our function contains only sine, our integral contains only sine omega x, then we have to go for Fourier sine integral. Similarly, if our function in the integral contains only cos omega x, we have to go for Fourier cosine integral. So remember all these small things, and you will be able to decide your Fourier cosine, sine or Fourier integral. This question was asked in GTU winter 2021 exam. You are asked to find Fourier cosine integral of pi by 2 times e raised to minus kx. We have discussed how to find out Fourier cosine integral of e raised to minus kx. So you can do the same procedure for this also. Here value of k is 1 and we are given pi by 2 as a constant multiple, but method is same. You have to decide what is your a omega, and once you obtain a omega, you can use the formula of Fourier cosine integral as integral from 0 to infinity a omega cos omega x d omega. And if you are not able to find out this, you can ask me in comment section. We will upload video for this question also. But because we have done this similar question in this lecture, e raised to minus kx, I am not doing this. Here, using Fourier cosine integral representation, show that 0 to infinity cos omega x over k square plus omega square d omega is pi over 2k e raised to minus kx. So this we have done, so I am not doing this. This can be done using Fourier cosine integral, which we just discussed. Here we can go for Fourier cosine integral of e raised to minus kx. Here we have obtained Fourier cosine integral of e raised to minus kx, and you can see using this we are able to prove that this integral is equal to pi over 2k e raised to minus kx. So this is just what I discussed about this. So in this way you can decide value of given improper integral using Fourier cosine, Fourier sine or Fourier integral. So this is all about this session. I hope you like it.